Good morning, my dear friends. Today, I want to discuss about field investigation works for soil formation. In fact, quite a good number of my beloved friends, they are repeatedly asking me to give some information about field investigation process and what to do and what shall not do. Actually, they are also handicapped. Uh, More than 50% of them they agreed that during undergraduate classes, because of 2 years of COVID, they did not able to go for practical experience for field investigation. So they want some basic requirement and basic methodological approach for field investigation. I told them very frankly that I am not at all expert. I do not know ABC of anything, but I shall be trying very honestly not to misguide anyone. They most of them they do not able to go through field investigation and for project reports, and due to serious condition they are making everything in online, so they are not able to go for even just a nominal laboratory test. They are able to learn, and they did not able to even go for major project works where field investigation and little elaborate laboratory testing methods. So they are insisting me, they are rather demanding me to give some basic knowledge about it. I am trying my best with my little knowledge and little experience in this engineering soil. I am planning, and accordingly today I shall be discussing on field investigation. Basically, this geotechnical engineering is comprises of three parts. One is field, where boring, drilling, sampling, and some field test, and another part is laboratory analysis testing. It has basic some guidelines also in IS 2720 with various different parts. And another part is interpretation of test results. See, it is very difficult to comment a test is correct or wrong, because in my more than 50 uh, 3 years experience in this field, I am still not able to make a plastic limit test. I cannot make the hole inside the this pencil plastic limit, this specimen where there is a hair-like hole is there. I cannot make that. Still, I am sometimes still I am trying to go for that, but I cannot. So there are I never say that this test is wrong, this test is correct, this procedure is wrong, this procedure is correct. So it is very difficult to 100% accurate, and as per codes, you one shall get everything very correctly. The the field, the basic aim of the field investigation is to ascertain the geomorphology of the project site, geoformation details, local history, local geography, local geology, formation details, everything we have, it is very important. Further, the thickness of all stratum with megascopic soil identification its site, texture, color, formation slope, etc. are also essential part of this investigation. In situ soil or rock behaviors and necessary field test like SPT, DCPT, SCPT. SPT is the standard penetration test which was developed long back, and DCPT is dynamic cone penetration. SCPT is static cone penetration, and collection of disturbed soil samples and undisturbed soil samples. These are the basic need. Further, the measurement of subsoil water table, that is record of subsoil water level and soil moisture, approximate unconfined compressive strength, etc. very has a very important role in further interpretation of test results. Indian Standard Code 1892, which covers how to make drill hole, what shall be the what type of hole is required, and what is the diameter, what shall be the minimum diameter, maximum diameter, and IS 2131, that is standard penetration test, and IS 2132, it is collection of soil samples, basically undisturbed soil samples. That code suggests the details with diagram complete. These are also widely discussed in all standard textbook, especially of undergraduate courses. You see, this arrangement is made for boring. It is the hydraulically operated drill machine. One bead is attached with the rod, and hydraulic pressure can be applied at a uniform rate of penetration, and rotation can be controlled from 50 rpm, 25 rpm. It shall be decided on the formation. If it is more sticky, rate of penetration shall be less and rotation shall be gentle. And if it is loamy soil, rate of penetration slightly higher than the stiff clay deposit, and rate of penetration shall be lower as far as practicable, because the the bore water, that means bore water means boring fluid, which shall be prepared using 5% of bentonite to stabilize the hole, unless we are able to provide casing, because initially we have to make the bore, and then later on casing shall be separately rotated and penetrated gradually. And next step, after lowering of casing completion, complete lowering of casing, we can go for next stage boring. So it shall be very carefully, it can be regulated with one gentleman here, he can do everything. This is the arrangement. There are many type of boring is there. One is wash boring. Normally we are applying water through a pump set and removing the spoils, and then at the required depth we shall be going for test. And another is simplified mud bore. That simplified mud bore is uh, manually done rotary bore. Rotary bore, we are mechanically rotating the cutting saw, cutting bit, cutting chisel, whatever we use. But it should be mechanically, it is generally mechanically operated, whereas the simplified mud boring is a method where no drilling machine is required. Rotary drilling machine is not required. It can be rotated manually and gently using mud water. Same mud water, normally here also we are using 5% bentonite clay, and that simplified boring also 5% bentonite clay. Percussion drilling, however, percussion drilling is not allowed for investigation purpose, because this pressure inserted underground with a very high pressure. It is about 20 kg per cm square, that is 200 ton per meter square, which normally affect the bore soil of entire bore area up to a reasonable radius, which is, say, for 10-meter bore, if you are drilling using percussion drilling, the entire area of depth equal to diameter or half radius of the soil is disturbed, because this operation is constant hammering using high pressure, 20 kg, 20 bar pressure, using 20 bar pressure, we are constantly hammering. That means we are compacting. At the same time that vibration cell affected our soil up to a radius of half d. D is the depth of boring. So normally even in very where there is very thickly built up that areas, if it is surrounded by the sufficient buildings, then percussion drilling may produce some amount of effect in nearest structure too. I therefore suggested the percussion drilling should not be used for boring or drilling operation for investigation purposes. The bore size is normally 150 mm for smooth collection of 100 to 75 mm dia, simpler. We require 100 to 75 mm especially for clay soil where we have to go for consolidation test. In consolidation test, we require 75 dia. So, if we get 100 we can cut the specimen by the cutting consolidation apparatus where one sharp portion is there which almost like undisturbed split undisturbed simpler area ratio where the area ratio is very less. So with help of that portion of the consolidation we can take cut out required dimension from 100 dia for consolidation test. However, however, where we do not require consolidation test, in such cases, 100 dia bore may also be purposeful provided our undisturbed sampler shall be 40 to 50 dia. If we can provide 40 to 50 dia undisturbed samples, then 100 dia boring is sufficient for conducting standard penetration test. I'll say this is standard penetration test. This is standard penetration test. This is dry weight. This dry weight originally it was 140 pounds. When we are converting pounds to kg because of this kg system, gram GCS system, gram centimeter meter system, then automatically our this dry weight became 63.5. In between some earlier, just after crossing, after converting this 140 pounds to kg, then initially all over the world it was considered as 65 kg. Later on, it was reduced to 65 kg plus minus 1.5 kg. One plus minus 1.5 kg was made because it was if 140 is converted to kg, it is 63.5 kg. Later on, it is 63.5 kg. There is no plus minus is there. Earlier, it is plus minus 1.5 kg. Now it is taken as 63 kg. This standard penetration test, the earliest penetration test. Earlier, there was no dynamic cone penetration test, no static cone penetration test. And in my opinion, during more than 53 years experience, I have conducted many, more than several thousands projects, at least 10-20 projects per year. And all these 10-20 projects are major projects because our establishment cost is too high. So we do not afford to be associated with small projects. So that is a major project we are doing, and everywhere I saw the dynamic cone test results never give proper correlationship as per IS specification and with some other standard textbooks. So I do not find, because after penetrating some time, the refusal value is obtained. So I do not prefer to depend on dynamic cone penetration test and static cone penetration test. I do not have so much of faith. And another problem is there, you see, these tests can be very smoothly conducted in soft clay deposit. My dear friends, I am hesitant to provide foundation in any soft clay soil, because say my load will be coming per meter square, per, per, per year it will be 1000 ton or like that, minimum 1000 ton. So I cannot want to take risks of 1000 ton on the basis of dynamic or cone penetration test results. And like this, another field test is there, in situ vein shear test. Code is confined. Code is confined in soft clay soil having n value less than 5. What shall be our practical use? In, in such depth, I cannot go for any foundation. Clay soil and value less than 5, I cannot go for any foundation. In case of pile foundation, that portion I have to consider that the unsupported length, soil strength is virtually very poor. But at the same time, it has important role in academic purposes and research purposes. If someone interested to go interested to carry on some research works for him, SPT, DCPT, and SCPT, all these are essential. Venture test also for comparison, comparative study, these are essential. Minus the academic and research purposes, these are for me, it is no purpose at all. These standard penetration test results and value that is directly related with this with the relative density, besides indirect relationship like with elastic modulus, shear strength, and frictional angle for C0 soil. Even envelopes are directly used for estimation and SBC and settlement too in Indian standard. In British and American standard, they used some empirical values, uh, n divided by 14 equal to SBC for sandy soil, and divided by 8 equal to SBC in clay soil. They standard some relationship they established. ASTM and BSS, uh, all these are in India also. We are our course, especially H6, uh, uh, especially IS 6403. They How to calculate, there is a rule also how to calculate SBC and settlement from N value. And in IS 8009, there is a specific relationship is SBC is proportional to uh, settlement, which I have some, uh, I have feel uncomfortable to accept that SBC is proportional to settlement. It is SB settlement is not arithmetically proportional. It is not arithmetically proportion to SBC. I had already presented some discussion about proportion whether SBC proportional to settlement. I have shown it proper applying proper theoretical estimates where it is not directly proportional. And IS 2911 has suggested to estimate pile foundation capacity using N value. They modified one equation, and that equation is they have suggested for a N bearing and skin resistance of pile foundation on the basis of N value. Uh, these values are for sandy soil almost equation. I cannot say equation is very wrong, almost very close to uh, static equation of IS 2911. Mainly for sandy soil, this equation is perfectly, it is very close. There is a good relationship between this uh, N value equation and static equation of IS 2911. The results are very close. This test is conducted at field using standard split spoon sampler with a driving weight of, as I told earlier, 63.5 kg. This 63.5 kg from a free fall of 75 centimeter. That is 750 mm. From this base to this base. It shall be perfectly vertical, and just here it is this releasing the load with the help of machine so that it shall be perfectly vertical as far as practicable. And blows are taken in three parts of 15 centimeter equal. Total penetration shall be 45 centimeter, and first 15 centimeter shall be neglected as the soil formation considered to be little bit soft due to use of boring fluid, bore water or mud water, what we call, and numbers of blows required for second and third 30 centimeter, that is 15 plus 15, 30 centimeter shall be considered as N value. However, it requires some two-step corrections for fine grain silty sand. One is overburden correction, another is dilatancy correction. These are very simple correction. There is for overburden correction, this N value multiplied by 2 divided by 1 plus overburden pressure under bracket, whereas where this overburden pressure in kg per centimeter square. We can use with this equation, we can go for overburden correction N0. I am giving N0. You can give any other notation. It is N0 means overburden press corrected. So I am giving N0. There is no hard and fast rule one should be written as N0. But this equation is everywhere same. Only this overburden pressure limitation is zero point 0.5. Lower limitation is zero point 0.5. Say if we go for at a depth of 30 meter where approximately 3 kg will be overburden pressure, 1 plus 3 equal to 4, 2 divided by 4 in it will be zero point 0.5. So it shall be multiplied and value multiplied by zero point 0.5. A 0.5 is this correction factor shall not be lower than zero point 0.5. And dilatancy correction is I am donating it NE equal to 15 plus N0 minus 15 by 2. Only a first dilatancy correction, only second this correction if N value exceeding 15. But all these corrections, they mean overburden correction in all formation we required, but the dialectics correction is required only for fine grain silty sand. This dilatancy correction only required for fine grain silty sand, whereas overburden correction is for required for all type of formation. I am writing here, overburden correction factor varies from 2 to 0.5 only. We shall not go for 0.5. Now, another thing you see, I am showing here, this is the sample recovered. This is the sample recovered. With that sample, we are measuring the soil moisture. We are measuring the soil moisture. We are estimating the compressive strength. It is not 101% actual compressive strength, but it shall give you approximate compressive value using this pocket penetrometer. This pocket penetrometer value, it is long back. This pocket penetrometer was approved by ASTM, and we also used in India to verify its site. We cannot go for with big machine or anything else at site which to minimize the cost. We are also using here at site. Say someone visiting the site where the work is going on, we are taking this pocket instrument and we are checking the compressive strength. We are getting the soil moisture compressive strength. I shall discuss later on what shall be taken. Now you see, for settlement SBC, we have to select the N value. Average N value we have to select from the foundation base to a depth of significant depth. The significant depth, up to a significant depth, we have to collect. But IS Part 1, IS 8W9 Part 1 suggested a very lengthy method. It suggests that as all the values should be plotted, not plotted, and and values for every 75 centimeter interval should be measured up to should be recorded up to a depth of 1b, 1.5b or 2b. They are not confirmed, it should be 1.5 and 2b. Actually, 2b is Bosiniak stress distribution theory and 1.5b is Westergaard stress distribution theory. Because you see, 2b, when we are going for 2b, then our SBC will be little higher because our any case our n value shall be increasing proportionately with depth. That means 2b, that means we will be getting little deeper, and settlement also when our significant depth will be 2b, overburden pressure at mid height of the significant depth, it will be little higher than 1.5b. Significant depth of 1.5b, it will be 7.75b. Here it is 1b. So there is a difference of 25%. For bigger foundation say 4 meter by 4 meter foundation, then it will be half meter. No, it will be half meter. So, or more bigger foundation, it may be much higher. And the distribution of stress shall be much less at 2b, and it will be about 10 to 20 10 to 50% at 1.5b. So indirectly many peoples they have suggested 1.5 is better, 1.5b is better. Since here b is, in case of settlement analysis, we are getting less settlement at this depth, twice b, whereas we are getting here it is little amount is higher. Then in case, of course, it will be about 10% only. To significant depth, if you consider 2b, then it is much less, about 10% less than the 1.5b. IS 8009 Part 1 has suggested that it should be, n value should be at 75 interval, and it should be average shall be taken from this value up to 1.5b or 2b, and if any individual values more than 50%, then the average value, that individual value shall be neglected and recalculated. So to avoid that, another equation is uh, Bowles, he has suggested to estimate the weighted average of n value. He suggested this equation NW equal to 3n1, 2n2 plus n3. In his opinion, this n1 will be first 50% of which he has considered 1.5b. First 50% of b, that is 1 and 1, and second 50% that is and 2, and third 50% third is 0.3. So this is his equation. And as per his idea, it should be divided by 6. It should be divided by 6. Oh, it should be divided by. It is not coming. Why I do not know. I am not able to write. It should be divided by 3. Please write. It should be divided by 6. However, what happened I do not know. Something is wrong with my computer. It should be divided by 6. In his opinion, up to the up to one third of one third below the base, this portion is this portion is heavily loaded. There will be no sense in stress distribution up to one third be below, and from one third to one third to two third below base level, there will be 50% of sense, 50% of reduction of stress, and here it will be in this portion, this 1b to 1.5b, in that portion it will be very nominally loaded. So he loaded pattern, he was divided into 3 parts. One is 100%, another is 20%, another is 10%. He has distributed in this way. He explained this equation in an international conference where he has discussed this equation in this way. Now you see, this is SPT as I shown earlier. It is SPT sampler. This is sampler. Here is one adapter is fitted, which is connected to the drive rod, and here it is shoe is fitted, which shoe is made of uh, surface hardening steel, and with that hammered down, and after collection we have to take, first we have to measure the recovery length. We have penetrated 45 centimeter. How much recovered? The recovery ratio is directly related to the formation. If it is the very hard soil, the recovery expected to be 100%, at least minimum 95%. Stiff soil, then it should be 90% above. Very soft soil, it shall be 70%, 50%, like that. So recovery is very important information for interpretation. This recovery, good recovery ratio for dense and hard soil, and poor recovery ratio stand for loose and soft formation. If possible, as I told earlier, in situ moisture content may preferably estimated at field using rapid moisture content carbide type, where carbide react with soil moisture, give acetylene gas and calcium hydroxide, which deflect the reading. There is reading. Some are developed 100%, some are 50%. In case of 50%, that should be 50 divided by water moisture meter reading divided by 50 minus that moisture meter reading. That will give you soil moisture, that equation. An electronic moisture meter also, anyone can use electronic moisture meter. There is no correction. It will be, once you set the 0.0 level, it will give measurement uh, very accurately, not like that of the oven dried, but it will give good results. In case of clay soil, unconfined compressive strength KUU, which I am saying using pocket manometer, we can find out that it is very essential information for later, and value is about 90% accurate. This value is about 90% give you correct value. Has important role in proper application of selection of primary soil parameters. Another problem is there. In many cases, in most cases, we may not get good core for conducting. You see, how much specimen you require? We require, require for, if we go for triaxial, we require uh, to 6 diameter, a piece of 6 diameter. That means we require three test piece, 2D, three, six, 6 diameter for one test, and one test for unconfined compressive string. That is also 2 diameter, and say moisture density. For that purpose also we require 2D. So we require minimum minimum we require uh, minimum 10 diameter to fulfill our requirement. As such, we may not get so much of good core. As such, if we conduct if we collect some information from the field data, we can incorporate it with our final laboratory data. At least we can take a decision for that formation. However, I am not in support of conducting dynamic cone penetration test and aesthetic cone penetration or vein shear test other than academic interest and research purposes, except very soft stratum. Anyway, deep foundation may serve as alternative proposition. Now you see, at site, we have to collect the undisturbed soil samples. Undisturbed soil samples, there are different sizes is there. The one sizes is 100 diameter, another is 75 another is 50 and minimum size is 40 Below 40 there is no undisturbed sampler even. These are thin wall. These are called thin wall sampler. These are required collected at a suitable interval for proper representation of each stratum under static pressure using hydraulic drilling head. Hydraulic drilling head means you see in this machine, in this here one rod is there. In this rod, if we fix the undisturbed sampler and under pressure, if we penetrate this under static pressure, it will be totally static, there shall not be other forces, then if the status of the sample is very good quality, there will be no extra disturbance, it will be statically penetrated, and at the time of taking out, gentle 5 6 turn gentle rotation shall be made, and then pull it out. If we do not rotate 5 6 turn, if we do not rotate during shear, there may be some damage of core inside. So it is a rememberable thing that after penetration, at least 5 minutes shall be rest to come the soil has some disturbance during static penetration, although the size of the tube is very small. It is about 1 to 1.2, maximum one nearest to 1 millimeter, and in the sharpen. So very and gently pressured under static gentle pressure it is penetrated, and after full penetration it should be kept for few minutes for rearrangement of materials particles. It shall be detached. No, it's a time, some amount of time is required. Allow he to attain the normal state. So after that, few turns will be rotated. Say 5 6 rotation. It is gentle pressure. It should be rotated for to detach the sampler with the soil. The soils at sampler and the ground to detach it. After that, we should gently pull out, maintaining the water level at ground level. If we do not maintain the water level, there will be some hydrostatic pressure difference, so it may not come up. That very carefully collection should be very careful. And the sample shall be collected at a suitable interval. Basic purpose, you see, it shall be very proper representation of soil stratum. If possible, say 1.5 meter or 1 meter, which is feasible to collect this sample. More sample, if we get more sample, it is better for us. If we do not go for more sample, at least what less sample we are taking, say at least big thick stratum, say 10 12 meter stratum. In that stratum, minimum 3 at top portion at 1 UDS, at the middle 1 UDS, at the last portion 1 UDS. At least we should take 3 for very thick stratum or very small stratum. Minimum we have to take minimum one sample any cost. And this UDS sample should be soon after recovery. That should be first this symbol, this arrow. That means this side is bottom and this side is upper side. our ground level, and this is the, say it is collected at 10 meter. Here it is 10 meter. Here it is, say, 1045 or 1050, whatever it may be. This is that. That should be noted separately, but these arrows should be written there, and both and sealed with waterproof paper and molten paraffin to retain the soil moisture. The soil samplers shall require to wrap with moist jute bag. Jute bag, whether it is nowadays available or not in every places, but in our places, jute bags are available where sugar is coming. शुगर जो शुगर शुगर का बैग जुट बैग आता है शुगर का बैग लगाने से और जुट जुट क्लॉथ इज अवेलेबल jute cloth it should be wrapped with moist, that means spraying some water, it became moist jute bag and stored in underground pit of 600 by 600 by 600. The depth shall be 60 meter, length should be 60 centimeter, and width shall be 60 centimeter. 60 centimeter by 60 centimeter by 6. And after placing the sample bag with wrapping with moist jute bag, we shall keep this sample in this bag and backfill it. Immediately we shall be backfill it with same soil to protect soil from moisture loss due to evaporation. The length of sampler shall not be less than 10 diameter. Here I am showing it. 2 for 2D for triaxial shear test, 2D for ECS unconfined compressive strength, 2D density, moisture, all this related, and consolidation we shall be going for remolded samples, remolded sample using this density. Another important aspect is field investigation is record of subsoil water level. In many cases, I found the people pay less interest about the recording of subsoil water level, which is a very wrong concept. Water level has an important role in SBCN settlement analysis, research, construction planning. If we do not know about the subsoil water level, our builder or project planner, they will be suffering. Construction planning is entirely based on subsoil water level study. The water level shall preferably be recorded initially at the time of encounter and thereafter every 24 hours interval before starting a boring operation for at least 7 days. And weather condition, whether it is fair weather, rainy weather, and hot weather, everything shall be co incorporated for proper interpretation. Because say water level is far below, then any season we can go for underground works. Water table is close to ground level. If there are possibilities of raising up then that period is not suitable for go for construction works. So for that reason, we are requiring water level, accurate assessment of water level. Further, our SBC, our unit weight of soil is an important factor, important parameter in SBC and settlement analysis. We therefore, if we do not sincere to record the water level, in such cases we will be in problem. So I feel it shall be useful. My dear friends, I am planning to discuss on rock dealing and rock core collection very shortly as early as possible. My always regards to my beloved friends, to all of you, and I am very much thankful to your all this demand of saying something on field investigation and laboratory investigation works. I shall be continuing. I shall be trying my level best to fulfill your demand, and I must sincere to follow your orders. I pray God for your all well in coming days. I am always available in jcgogoi at gmail.com. I am repeating, I am always available at jcgogoi gmail.com. Thank you. Please be happy. Please be healthy. Please be blissful and contented.